Toss a coin. Heads. This result is a fact. But what do we know now about future results? Are any future coin toss results invented by tossing coins? Or are they already out there, waiting to be discovered? And more interestingly, is truth in general invented or discovered? All this talk about coin toss results existing independently might sound preposterous, but that's actually exactly how mathematicians have thought about mathematical truth for centuries. This position is called Platonism, and it's how we're intuitively taught to think about math at school. For a Platonist, math really is about venturing into another realm and discovering predetermined truths. However, an alternate view does exist, intuitionism, which argues that math is actually grounded in human mental constructions, that decision procedures are needed to establish mathematical truth. But generally, this view has been sort of philosophically subordinate to Platonism in the past. Until now, that is. In 1976, Haskell Curry and William Howard produced a correspondence that proves that structurally, proofs and programs are really the same. They established a parallel between math and computation, and in this video, I'll discuss 3 implications of this parallel that might just shift our understanding of the nature of math. One idea is that programs must be executed to produce results. So if programs structurally are proofs, proofs too must require some sort of activity. This supports intuitionism's view of math as an act of mental construction, undermining Platonism's belief that math is separate from human activity. In addition, we know that any program necessarily requires hardware to run. And guess what? A hallmark of the intuitionist stance is that math is constructed in the mind, a sort of hardware in itself. This, again, isn't proof of Platonism. We also know every computer program must have a non-zero runtime. And this too is exactly how intuitionism needs mathematical truth to be built up over time, an idea that isn't necessarily a feature of Platonism either. And so really quickly, we've seen 3 ways in which viewing math as a program via Curry-Howard aligns with intuitionism over Platonism. Ultimately, for me, when I think about how profoundly computation has shaped our lives, I wonder if it ought not to also have a voice in the way we think about mathematics. The Curry-Howard correspondence, indeed, suggests that it just might.